Need me to slow down or do another example? Does that sound good? And someone is more than welcome to turn the light off in front of the room. All right, guys. So the conversion we need for degrees to radians or radians to degrees is that 180 degrees is equal to pi radians. So I just think of it as this is radians. So I'm doing dimensional analysis. I need the radians to go away. So I need the pi down here and the 180 up here. So these divide out. You could just do it on your calculator. That's going to go in there 20 times negative 760 maybe. Anybody checking me? Yes? Okay. Rather than do another one of those, do you want me to do one of these degrees to radians? This time we need the degrees to cancel. So I'm going to put the 180 on the bottom and the pi on the top. And then I would just do, it's going to be an exact choice. So I would do 405 divided by 180, math, enter, enter. And it's 9/4. Did anybody get that? So you'd have 9 pi over 4. Okay. We good on those? All right. Then I'm talking some kind of law, sines, cosines, and you have to decide. Number 5, remember capital letters are angles, lowercase across from them are sides. This is 60 degrees. B is 28 degrees. I think I can just do law of sines because they're already across from each other, right? So I have the sine of 60 is across from C in the same way the sine of 28 degrees is across from 7. What mode do I need to be in? Yeah, the angles were in degrees, so I need to make sure I'm in degrees. And then 7 times the sine of 60, close parenthesis, divided by the sine of 28. Anybody get in 12.9? Did someone else get that? Okay. Number 7 says find an angle, but I think it's law of sines again, right? A, B, C, angle C is 128. Okay, obviously didn't draw that accurately. 29 is across from it. Angle B, I don't know, but side B is 12. So I can set up the sine of B is across from 12 in the same way the sine of 128 is across from 29. Does anybody remember that this is the ones where you could have 2 solutions? This one is not going to have 2 solutions. But when you do 12 times the sine of 128 divided by 29 and you get a decimal, .326, then what? Remember what that means? That's the sine of B, right? And then when you do inverse sine of that angle, you're supposed to do the supplement of that as well. Now, second sine of that long decimal gives me 19 degrees. 180 minus 19 degrees is 161 degrees. Can angle B up here be either one of those? Can this be 161? No, because there's already 128 in this triangle, right? And it's not across from the longest side anyway. But that's the kind where you would have two possible angles. I don't think there's one with two solutions on the quiz, the final, but well, this is another one. Maybe this one has two. I don't know. ABC, 30 degrees, across from B is 28. A is question mark and 29. If we set it up, the sine of 30 degrees is across from 28 in the way that the sine of A is across from 29. So if I type 29 times the sine of 30 divided by 28, and then I do inverse sine of that answer, 29 sine of 30, close parenthesis, divided by 28 is 0.5178. If I take second sine of that, I get 31.2 degrees. Because I did inverse sine, I'm also supposed to do the supplement of that. Supplement of that is 148.8. Remember, that's only when you're doing inverse sine. And the reason for that has to do with the fact that the sine graph, if you were in degrees, this is 360, this is 180. And the sine hits that decimal, which was 0.51. The sine hits that 0.51 twice before 180. It hits it at 31.2 and it hits it at 148.8. So either one of those work until you look at the triangle. Then you got to decide. Comments? They both work? 148.8, can this one be 148.8? Or 31.2? If it was 148.8, we'd have 178.8 degrees, but it would still leave something for C. I know some of you just want to go, well, that's just not right, but it does work. Both of those would work. You would just have a really long, you'd have a really tiny angle over here. All right, I'm assuming we get to law of cosines. This one has an angle A that's 120 degrees and a side on either side of it that are 12 and 29. We're trying to find side A. How does this go, guys? How does law of cosines go? Okay, I could be done for the day. How does law of cosines go, guys? Okay, so what numbers are we plugging in from this picture? (29 squared) Okay, and you have to type it all in. This all goes together. You cannot separate it. I would just type the whole darn thing in. And I got 1333. Anybody else get that? No? Yes? Okay. Is that the answer? This side is 1,333 units long. We got to square root that. So I have 36.5, which seems reasonable because it's across from the longest angle. Okay. Then I'm guessing there's probably one where we have to do law of sines backwards. This is not. Anybody know what you'd have to do here? Wait a minute. This was supposed to be 7. This was 15. Yeah, you do law of cosines to find this side, and then you could do law of sines to find angle B. I don't think there's one that you have to do in 2 steps like that, so I'm going to skip that one. I was hoping though. No? Are there none where you're given 3 sides, guys? Well, only to find the area, right? All right. 15 is find the area of this triangle. Read questions carefully, guys. 13, 15, and 76. Anybody know this area formula? It will be on your reference sheet. It's on the reference sheet. On the back in a little box here, okay? This one doesn't have it. It only has law of the area for the other one. But does anybody remember how this area goes? It's 1/2 AB sine C, or 1/2 2 sides times the sine of the angle in between. So we'd have 1/2 or 0.5 times 15 times 13 times the sine of the angle in between. And that formula is on there. Anybody get 94.6? That's supposed to be an M, square miles. Someone else get that? Yeah, okay. So this formula will be on the reference sheet. All right, the other possibility for area of a triangle, and that formula is on there as well. These are kind of disgusting. Is S equals A plus B plus C divided by 2, and then A equals the square root of S times S minus A times S minus B times S minus C. Do you remember this fun rule? This is Heron's formula. So the first thing we have to do is add up all the sides. Make sure we divide that by 2, meaning the whole thing. So I got 15.25. That's lovely. So then we would have 15.25 times 15.25 minus 4 times 15.25 minus 13.5 times 15.25 minus 13. And then we'd need to square root that all. I get like 675 point something. And when I square rooted it, it's basically 26. I kind of want to do a law of cosines question, and I feel like there isn't one on here, where you're given 3 sides. So you want me to make one up? Because I feel like that's on there, but maybe not. If you had sides of 9, 11, and 14, and you're trying to find this angle here, what would law of cosines work with? Look like? You'd say the one opposite the angle equals adjacent squared plus adjacent squared minus 2 times 9 times 11 times a cosine of x, we'll call it. But how do we type this in to get it right? I have to do 14 squared and then what? Okay. And then I've gotten rid of these. All of this is multiplied, so I'm going to end up dividing by all of this, and that will give me the cosine by itself. So the top, I'm going to do it in parentheses just like I wrote it. 14 squared minus 9 squared minus 11 squared divided by the quantity -2 times 9 times 11 inverse cosine at 88.3 degrees. Did anybody else get that? Okay. We're good? All right, so that should take care of law of sines, cosines, and area. Then we move on to vectors. Find the magnitude of a vector. Who remembers that? There's about 4 things you got to know about vectors, and there is no reference sheet, okay? The magnitude, okay, or R, and it's the square root of x squared plus y squared. The direction is inverse tangent y over x. And if you happen to be given those 2 things, magnitude and direction, and you're trying to find components, you find the components by doing r cosine theta and r sine theta. Just coming back to you guys. Okay, so what do we need to do for number 19? Yeah, this is an x, this is a y, and they want the magnitude. So we just do 24 squared plus 32 squared, and then we square root it. Is it 40? Questions? All right, 21 says find magnitude and direction. So magnitude, we're still just doing the same thing we just did. I got 34 for the magnitude. Now, what tangent should our direction angle be in? What did I just say? What quadrant should our tangent angle, what quadrant should this end up in? It's a positive, so it should be in quadrant 1. So if we do inverse tangent of y over x, what mode am I in? Yeah, degrees. It hasn't asked us to find this in radians, so we usually find angles in degrees. I have 61.9 degrees. Is that okay? I'm in quadrant 1, right? So I don't have to do anything crazy to it. If you were doing this one over here, and you did inverse tangent of negative 48 over 20, what quadrant is that in? Positive, negative. 20, negative 48 is down here, right? So when I do inverse tangent, negative 48 over 20, I get negative 67.4 degrees. Is that in the right quadrant? Yeah, you could add 360 to it, but it's okay to just say negative 67.4 as far as I'm concerned. But if it's not a choice, you'd have to add 360. All right, when you get to these, oof, these were bad. Anybody remember how you find the components? You have to find the components going from A to B. And then you find magnitude and direction. Whoa, sorry. I don't know what I just did. The definition for the components are the second x minus the first x and the second y minus the first y. So it would be 5 minus 10 or 3 minus negative 10, because it's how did you get from A to B? So from 10 to 5, you went down 5. And the y coordinate from negative 10 went to 3, so it went up 13. Everybody get that or not? From 10, it went to 5, so it went down 5. Or you just take the second one minus the first one. From negative 10, it went to 3, so it went up 13. Or you take the second one minus the negative 10 of the first one. All right, we're not done though. We didn't find anything we needed yet. What do we have to do now? The magnitude is square root of, this is what everybody got wrong, even if they did the first part right. Guys, just leave the negative off when you're doing Pythagorean theorem. Just type 5 squared plus 13 squared. If you don't, and you put the parentheses in the wrong place, or you forget one of the parentheses, you get the wrong answer. Literally had 3 people retake that on the last day, and all 3 of them did that wrong. 13.9 is the magnitude. And the direction, what quadrant was this in? Negative 5, 13 is over here in quadrant 2. Okay, we need a quadrant 2 angle. So if I do inverse tangent of 13 over negative 5, it's going to give us the wrong answer. Got negative 68, basically negative 69. Okay, it thinks we're down here. Do you remember what we do? Yeah, add 180. So if we add 180 to that, it's 111 degrees, should be the answer that's on the back. Anybody check the answers for that one? Number 23, 13.9 and 111 degrees. No? Yes? Okay. Apparently I thought we needed to do another one. Do we need to do another one, or we just need to do the first part, make sure we can find the components? What are the components for this one? Yes, from 9 minus negative 4, or from negative 4 it went up 13. And then 1 minus -4. From -4 to 1, it went up 5. Aren't those the same numbers we just had? Yeah, so it should be 13.9 for the magnitude again, but the angle this time should be positive 69, I think. All right, we can do another one of those tomorrow if you might want to put a note there so we review that again tomorrow. All right, what about 27? Any questions about these kind? You just take -7 times everything in the F, and then you take 5 times everything in the G, and then you add them together. So this would be 56, -42, -20, 25. If I add, I get, I don't know, 36, -17. Somebody fix me. That's probably wrong. 25, 32, 42. Is that right? Anybody check in number 27 in the answers? What? Okay, thanks. Any questions? What we did? Okay, 29. This is telling you that this is a magnitude. And it's given an angle. It says draw and find the horizontal. It says find the magnitude of each component. That just means find the horizontal and vertical components. Okay. So if you had drawn at 215 degrees a vector and labeled it 48 units long. Okay. Do I need to change that angle? Is it coming off the positive x-axis? Yes. That is the measure from the positive x-axis around. So you don't need to do anything with it. So the components would be 48 cosine of 215 and 48 sine of 215. So the vertical component, let's see, across is the first one, so that'd be horizontal. Yeah, -39.3. That would be the horizontal component if it asked. And 48 sine of 215, -27.5. That would be the vertical component. It's in the right quadrant, those numbers, right? Negative, negative. I don't know what the answer actually says because when it says magnitude of a component, it's usually not negative. So the answer might have positive, but it's not asked like that on the, it would just say find the component on the final. All right. You get to have this little chart. Remember the little chart that said what each of them was? And the chart looks like this for this one. It would say R equals ED over 1 plus E sine theta. So what do we need to do to this one? Nobody? Which number has to be a 1? So what do we have to do to all these parts? So we get 4/5 over 5 over 5, which would be 1, plus 4/5 sine theta. And it's going to ask, what is E? E is 4/5. Okay. And it could ask what it is, and it would tell you less than 1 is an ellipse. It actually looks like this on the card, but it's an ellipse. If it asked for the directrix, it would have said next to this up here, let's see, because it's sine, it's y equals So anybody know what this directrix? How would we find D? This one's ridiculously easy. Because this top right here is E times D. And we already know E is what? Okay, so E times D equals 4/5. But we already know E is 4/5. So we have 4/5 times what is 4/5. So D is just 1. So the directrix would be Y equals 1. I don't remember what it asked for. It might just ask for E. But you have the reference chart on the one of the reference sheets, okay? 33, you would go around 3 pi over 2 to this, and then you would go out to the radius of 2 here and label your dot. If you change this to -3, -60, guys, what quadrant would that end up in? Do you remember how this goes? Because you have to, what it does is it gives you an ordered pair and it gives you 4 pictures and you have to pick which one is graphed correctly. This would be -60 would be this line here. But because of the -3, you also have to back up. So you'd be in quadrant 2 right here. Everybody remember how to do those? Any more practice? Mackenzie, was that a no, I don't remember, or a no, I don't need more practice? Okay. I changed a couple of these. Let's just do this number 35. If you went around positive pi over 3 and then backed up 2, it would be on this line. Everybody good? This one would be -90 degrees and out 2. Okay. I changed those questions, though, because I think the ones on your sheet were all positives, right? Okay. Oh, great fun. Anybody remember what this means? It's really just vector stuff, guys. And what is this? And what is this? When you have polars, it's an r and a theta. So what can we do if we know an r and a theta? What did we have with vectors? R cosine theta, r sine theta. Made the ordered pair into an x and a y, right? That'll sound familiar now? Now, the issue for this is going to be you're going to have to use a unit circle. So if this is 3 cosine 2 pi over 3 and 3 sine 2 pi over 3, if you go to your unit circle, the cosine at 2 pi over 3 is -1/2. This becomes 3 times -1/2, or -3/2. And the sine at 2 pi over 3 is positive square root of 3 over 2. And we're multiplying, so we get 3 square roots of 3 over 2. And that's what it would look like for number 37. Anybody do 38 super fast because you know what sine and cosine of pi over 4 are? What's cosine at pi over 4, guys? Please tell me someone in this room has those memorized. Pi over 4, sine and cosine. Yes, these are both square root of 2 over 2. So you'd have 3 square roots of 2 over 2 and 3 square roots of 2 over 2. Because 3 cosine pi over 4 and 3 sine pi over 4. These are both just square root of 2 over 2. That's kind of scary, guys. Enough of those for today. If you want me to do another one tomorrow, I can. These our x and y, and they want us to find an r and a theta. How do we find r's and thetas? R is the square root of x squared plus y squared, and theta is the inverse tangent of y over x. Now, what is this telling us? If we're going to do these as decimals for the first time ever, our calculator needs to be in radians, okay? You would have had to be in radians for these, except we use the unit circle instead, right? All right, so for this one, if we do, well, first of all, you should be able to just graph this. If you go over 0 and up 1, what is the ordered pair, or what is the radius out to that spot? Well, if you do square root of 0 squared plus 1 squared, you get what? 1, yes? And what is the angle I'm at right there? Guys, what's the name of this on your unit circle? Pi over 2. If you do inverse tangent of 1 over 0, is that going to work? No. Okay. This one is at 0, across 0 and up 1, you are out a radius of 1 at pi over 2. I don't know that it's like that on the quiz, but you should be able to find that on the unit circle. Over 1/2 up square root of 3 over 2 is pi over 3. You'd have a unit circle, okay? And what is the radius? Well, what should the radius be on a unit circle, guys? That's a hot mess. What should the radius be if it is a unit circle? Thank you. Okay. So if I were you, could you take all the choices and do r cosine theta, r sine theta, and figure out which one's right? Could you work this problem backwards? Do you know what I'm saying, guys? Because it's multiple choice. Okay. So figure out which of these gives you the same coordinates. All right, this is just reading the unit circle. Anybody need help on any of these? Negative 5 pi over 4 would be 5 pi over 4 is 225. So if you want negative 225, it would be here. And the ordered pair there is negative square root of 2 over 2, comma square root of 2 over 2. So what's the tangent, guys? The tangent would be negative 1 because you would put y over x. Okay? I'm moving on. Should know how to do that. Find the limit. What could you do on either one of these because they're very well behaved? You could definitely graph them, but you could also just substitute the value in, okay? Because this is a well-behaved function, it's just a cubic, you could find it by just substituting in the value carefully, or you could graph it. I don't know, I got 4. Did anybody get the answer, or anybody graph it or find the... Is it 4? Okay. There's some with a graph. Does this have a limit at 0, guys? As you approach 0 from both sides, is it approaching the same y value? Yes, what is that y value? 0. What about this one? Does it have a limit at 2? You approach from the left and the right. Is it approaching the same value? So this one does not exist. I will skip to 57. You could definitely graph, but you could also factor. Does that work? And then put in a 1 to what happens after you divide it out. If you type that in, what would it look like when you were typing it in? You'd need what? Parentheses around the top and bottom. Can anybody read it to me? X squared minus 4x plus 3, was that right? Divided by the quantity x minus 1, did I remember right? Okay. Thanks. If you actually graph it, it's going to have an undefined place. What are we finding the limit at? 1, right? So 1 is going to give me an error, but the question is it approaching the same thing from above and below? What's just below 1? 0.99. What's just above 1? 1.001. Is it approaching the same thing? Yes. Okay. There are some identities. How are we doing on time? I don't have any idea. It says 10:11. Yeah. Is that when we're done? Okay. So I will stop with identities. How's that?